Hello everyone. In this video we're going to be restoring this beautiful motor which is badged a Craftsman and it was sold by Sears. This particular motor is what they call a long C Craftsman and it was manufactured in 1940. It's a 1/3 of a horsepower and it's a 4-pole motor and it's a Repulsion start induction run, and of course those are my favorites. This motor has a beautiful waterfall design and a strong Art Deco look to it, so it's really a nice looking motor and I'm looking forward to getting it running. I printed out a copy of the 1940 Sears catalog there, which I downloaded off of vintagemachinery.org, and there's some interesting information in that page. One of the things that it states is that these motors were built with Super Duty windings and Super Duty laminations. It also states that the motor has giant oil wells which are packed with wool yarn, and this motor was designed to never really need any additional lubrication once it left the factory. It states that they did put some screws there in case you wanted to put some lubrication, but that their engineers didn't feel it was going to be necessary. This motor has the prefix of 315, and the motors that were built with that prefix were built by Diehl, and Philip Diehl was the inventor of the ceiling fan and built some very high quality motors. This literature here states that this motor will start at 3 to 4 times its rated horsepower upon startup, which is why these Repulsion induction motors were favored for starting heavy loads. There's a little box here and it kind of ranks the motors from good, better, and best, and it shows the split phase motors as kind of like the entry level motors, then the capacitor motors as the medium duty, and then these Repulsion induction as the heavy duty. And Sears probably sold 1 million of their capacitor motors, which had like the chrome band in the middle, and they actually utilized a flat capacitor. Another interesting thing about this motor is it was priced at about $17 in 1940, which translates into about $330 of today's money. So it's kind of interesting seeing how much things cost back then compared to today. These leads here appear to be wired for 110. To wire this motor for 110, you wire the windings in parallel, and this motor can also be run on 220, and to do that you would put the windings in series. So anyways, it should be fun taking this motor apart and getting it running again, and hopefully you're going to enjoy following along. Okay, so the first thing I did before we begin any project is I took some pictures just around the outside of the motor, just kind of see where things are, and we're going to start taking this thing apart. Okay, so once I removed the end bell, you could see that this is the side of the motor that has the commutator, and the commutator appears to be in pretty good condition, as do the carbon brushes. They look like they have a lot of life left on them, so that's always a good sign. There's a few washers over here, a couple metal ones and a fiber one, so always take note of those, because you need to make sure that you replace them in exactly the same order they were before, so that you don't have any extra play from front to back. And as you can see here, there's a snap ring that's going to be holding the centrifugal switch mechanism together. In there should be some copper bars inside of there that are held together with a retaining spring, so eventually we'll be taking that rotor apart. This lever right here controls the direction of the motor. So if you want to change the direction of the motor, you just press that down and rotate that over, and that'll switch the direction of the motor. So we'll go ahead and continue taking this apart. Okay, before I try to remove this front end bell, I'm going to clean up this shaft just a little bit using a piece of sandpaper just to smooth out any burrs that are on there. Now when I remove this rotor, first thing I'm going to do is take a photo of these washers once again. Also, when I remove it, I want to be careful not to bang the rotor into these windings, because it's possible to make a little dent or a nick in these windings, which will screw up their insulation. So when we pull out this rotor, we're going to be careful not to break anything. We got the motor turned around here, and now I'm going to go ahead and remove the brushes. These brushes are joined by a little piece of copper wire. So, get these springs out of the way first. There's one. There's another one. Okay, just looking at these carbon brushes, they have a lot of life left on them. They're really almost in brand new condition. I do have a collection of carbon brushes, so if I need to change them, I would, but at the same time, I don't want to waste the ones that I have. So if I can reuse these, I'll definitely try to do that to preserve the ones that I have, and these look to be in pretty good condition. Here's the plate with the 4 flat springs. Overall, the inside of this motor looks to be very clean and in good condition, so that's always a good thing. Makes the restoration a lot easier. Okay, so in order to remove these flat springs, all you have to do is just take the pressure off of them. Once you have the pressure off of them, they just lift right off. I say that, and then it doesn't lift up. There it is, right there.
flat springs removed. Okay, so now that we got the bushings out, I can see that they need to be replaced. If you look at this one, it's quite a bit thinner on one wall than it is on the other. The dimensions of these bearings are 3/4 of an inch outside diameter and 5/8 of an inch inside diameter. So I got a couple on order from McMaster Car because I didn't have this exact size in my collection. So we'll get these replaced. Okay, now we have the oil wicking removed from the end bells, and these wicks appear to be in fantastic condition. Unfortunately, one thing they do not appear to be is saturated with oil. They're dry. I mean, when I squeeze this, oil should be pouring out of these things. So I think that's probably the reason why those bushings wore out, because these things are dry. But looks like we'll definitely be able to reuse those because they almost look like new. Okay, so I snipped off the ends of the windings here. So what I'm doing is I'm taking a little bit of red heat shrink tubing and just marking this one pair, and that will make it easier after I put new leads on here, just to kind of know which pair goes together. And you can see here I used the bolts that hold the motor together to, and I put the nuts on there, and that supports the motor up off the workbench so that the windings underneath here aren't rubbing on the workbench and getting banged up. So now what I'm going to start doing is pulling these leads out of here, and we're going to have to rewire those because all the insulation is worn off and there's bare wire sticking out here. So that's going to be the next step. Okay, so I got the hand crank megger out here, and I got it connected to the first lead coming out of the stator there, and I just made sure that none of the bare metal was touching the frame because these leads are in bad condition. But anyways, it should be good to go. So now we're just going to check the insulation resistance of these windings. Okay, so that one read infinity, which is as good as you can get. So that's a great sign. Now we're going to do the other ones the same way. Excellent. Let's try these two. Okay, those were excellent readings across the board. So we know that the insulation resistance on these windings is in great condition. So now it's going to be time to go ahead and repair these lead wires coming out of here so that we don't have any short circuits. Okay, so now I have all the lead wires repaired. I just went ahead and got some heat shrink tubing on all of those. And while I was in here, I also very gently cleaned these windings up just using a bristle brush and a little bit of electrical contact cleaner. And they really look nice. So now I'm going to go ahead and clean up the other side, and we'll start getting these things ready for some varnishing. Alright, so as you can see here, we got the paint pretty much stripped off the motor, so that will allow us to get into the steps of painting it when the time comes. So what I'm doing now is I'm just getting the new bearings to fit absolutely perfectly on the shaft. It's difficult to pick up in the camera, but there's just a little, very little bit of scoring in there from where the old bearings were allowed to run without any oil. So what I'm doing is I'm just taking some emery cloth and just cleaning that up a little bit. Here's another one of the new bearings. So what I'm trying to do is just get those fit on there just perfectly. And they fit good, except right here at the end they're a little bit tight. So we don't want any unnecessary drag on those new bearings if we could help it. So just puff those out a little bit more and be ready to go. Okay, so I have the shorting necklace removed from the commutator area, and there's absolutely nothing wrong with this spring or with this shorting necklace here. It looks to be in good condition, but since we have it apart, I'm going to show you how it works. The most common failure on this type of shorting necklace is that the spring just gets so stretched out that it doesn't function the way that it should. So the way that this operates is the spring holds these contacts together, holds them closed, and as the velocity of the motor increases, the centrifugal force on these contacts overcomes the tension on the spring, and they open up and they short out with the commutator. So when the spring is worn out and stretched out, that doesn't operate the way that it's supposed to. So finding a replacement spring, sometimes they refer to these as like a garter type spring, is almost impossible. They just don't make them anymore, and you're not going to go on eBay and search for garter springs for a 100-year-old electric motor, and you're not going to come up with too many search results. So the way that you can get around that, if the need arises, is you can go to a place like McMaster Car and you could order what's called an extension spring. And extension springs look like this. Okay, this is a 36-inch piece of spring. I have several of them there, and they come in different thicknesses on the wire gauge and different diameters, of course. This one is not exactly the size necessary for that, but I'm just got it out here just to kind of show you what you would do if you needed to replace that spring and you couldn't find a replacement. So what you would do is you would order an extension spring. This particular one is 0.125 on the outside diameter and 0.018 on the wire gauge. So what you do is you would cut off a length of what you would need for the circumference of the old spring, and then just use a very small piece of a threaded rod or a threaded screw that would thread inside there, whichever one would fit this size application that you're using. And then so then what you would do is you would put them in a circle, thread each side onto your little piece of threaded rod, and then you could hold it in place with a little bit of Loctite, and that will work as a band-aid if you need to do that. So there's a link on the vintagemachinery.org website that details the breakdown of a Delta, a Repulsion induction motor. Obviously this is a Diehl motor and not a Delta, but the principle is the same. And they have some pictures that accompany the breakdown of one of those motors and shows this and this and how to replace that. So anyways, if you need to replace that garter spring, that's the way that you're going to end up doing it, because you won't find a replacement for that readily available. So as far as this project is concerned, I'm just going to go ahead and clean up those contacts a little bit since I got them out, and clean up the commutator a little bit, and then we'll just put that back together. Okay, so now I'm going to give the contacts a little bath in the ultrasonic cleaner. I just got those in a solution of vinegar with a little bit of salt in there, and we'll just let those clean up in there. And while those are cleaning up in there, we're going to work on cleaning up this part, and we should be good to go. Okay, so I made up a little arbor, and I have this part of the shorting necklace on that arbor. And what I'm doing is I'm just trying to file out some of these gashes that are in there. What I'm guessing what happened was at some point somebody probably wanted to change the spring on that shorting necklace, and they probably didn't realize that this housing pulls off, that it's press fit on there, and they probably tried to unscrew it, and in order to do that used a large pair of channel locks or something similar on there, and that's what gouged that thing up. So I'm just trying to make that look a little bit better. So we'll just turn that in the motor and smooth it on out. Okay, so as you can see here, I'm cleaning up the commutator, and the commutator looks to be in pretty good condition. So what I'm going to do now is I'm going to go along in each one of these grooves and clean out any accumulated junk in there. In between these commutator bars is called mica, and what happens is if the bars wear down and the mica is exposed, that can cause a problem with sparking, or the motor not running as good as it could. So what I'll do is I'll take something pointy like this and very carefully just go in between each one and clean it out a little bit, just to undercut that a little bit. A lot of times you'll see people using an old hacksaw blade for this job, just taking it and running it in and out these grooves. But in this case, a hacksaw blade won't fit in between those grooves there, so I had to use something smaller. So I'm just using the tips of these tweezers to get in there, and I'll rotate that around. That's why I put this little mark here so I know where I started, and I'll clean out each one of those bars. Okay, so I've had the stator and the rotor sitting inside of a heating pad all night, and this is nice and warm to the touch, and these windings are nice and dry, which is a prerequisite for applying the insulating varnish. So once again, I'm going to be using this clear varnish. It's made by Spray-On. It's EL600, and that's available on eBay and Amazon. So anyways, I'm going to go ahead and I'm going to coat up the stator, and we're going to coat up the rotor. Okay, so we got these all varnished, and as you can see, they really look beautiful. The windings were already in pretty good shape to begin with, so this was a fairly easy job. But that EL600 varnish does a great job. And what I've done now is I pulled out my old trusty space heater, and what I like to do is once I get these coated, I like to run the space heater on it for a while it's drying, and just flip those around, and so that the space heater gets both sides of them. And once those are dry, they should be ready to go. Okay, so I just applied a little clear coat to the inside of the end bells and to these shields, and that's just to provide a little bit of rust protection. Okay, I'm at the part where I'm working on the cable gland area here, and the area where the wire comes out of the motor is commonly referred to as a peckerhead, and I didn't make that term up, that's really what they call it. Anyways, what was in here before was this nut here, and as you can see, that doesn't offer a lot of protection for the cable coming out. This is the cable that I already have on hand, So that's the one that I'd like to use. So my goal is to use this cable gland here, and the hole that was in this cable gland wasn't big enough to accommodate that cord. So I already drilled it out just a little bit bigger. Now I'm going to cut this in half, and this will fit inside of there, and the cord will come out, and hopefully this whole thing is going to have a nice, neat appearance when it's finished. Okay, so on these connecting rods, I went ahead and I cut off the flathead part, and I'm eliminating these nuts. And what I'm going to do is go with some nice nickel-plated acorns instead. So I just threaded that other side, and that should give it a nice appearance when it's all finished. Okay, so I have the majority of the wiring done inside the motor. The only thing I haven't done is actually attach the power cord, but we'll do that at the end. So what I did was, when I reattached the new leads on there, I have them soldered here, and then of course I use heat shrink tubing after I soldered them. And then what I did was I wrapped them around in such a way that I only have the 2 lead wires coming out of here for the power, as opposed to the 4 individual wires that were out there originally. That's going to give it a little bit of a neater appearance. So everything's been secured around here. I used a couple zip ties, and that should hold up fantastically over time. Okay, so we have all the flat springs back on, and they're all in the correct position, because it is possible to flip those over and put those on backwards, and then they won't slide back and forth as free as they're supposed to. And I also went ahead and adjusted each one of them to make sure that they're operating optimally. So these are ready to go. Now I just got to put the brushes in there. Okay, so I had a little bit of a change of heart, and I decided to snip off the zip ties that I had installed on those windings, just because I was a little bit nervous after I started thinking about it, about those being cinched down on there, and I decided that it would be a better alternative to use the friction tape on there. Plus, the friction tape gives it a nicer appearance anyway. So I snipped those zip ties off, and I went ahead and carefully put some friction tape around there, and I think that that's going to be a better job. So happy with the way that that came out. Okay, so I have the motor temporarily hooked up, and what I'm doing here is I'm using what's called a commutator stone to seat the brushes on the commutator. So all you would do is turn the motor on, and while the motor is running, you rub that stone on the commutator, and that helps the brushes to get properly seated on there. So it does create a little bit of dust, so it's good to wear a mask while you're using it. And now that those brushes are properly seated, I'll take that back apart real quick and just clean up the dust out of there, and we'll be ready to go.
Okay, so after having the motor running for a little while, using the commutator stone trying to seat the brushes, I noticed that the motor still has the same vibration that it did before I got it. When I first got the motor and I tested it out, I noticed that it had a little bit of vibration, but I just figured that once I put some new bearings in there, that would address the issue. And so the bearings in here have been replaced, but the motor still has a little bit of vibration to it when it runs. So I'm going to play for you a video now of the motor when I first got it, hadn't touched it, so that you can hear the vibration, and then I'll follow that up with a little video of how the motor sounds now, and you'll see that it still has that same problem. So we're gonna tear this motor back apart and see if we can get down to the root cause of the problem. Okay, so what I did was I started with the simple things first, and I tore the motor back apart. I just did this off camera because I already showed it in the video beforehand. And I replaced the bearings a second time. So the reason why I did that was because it is possible when you're putting in the bearing, you know, that perhaps I didn't put it in perfectly straight, or maybe when I was holding it in the vise to make the hole for the lubrication to come through, maybe I deformed it in the vise. Anything could have happened. So to eliminate any possibility that I did something wrong when I installed the bearings, I took those bearings out and I put a second set of brand new bearings in there, and I was perfectly careful with it to make sure that that wasn't the problem. So before we continue troubleshooting this vibration, I want to make it clear that that's already been done.
Okay, so looking at the back end of the rotor here with the fan on it, as you can see here and here, it's apparent that a previous owner, or perhaps at the factory, somebody in the past has tried to address the issue of the vibration, because they went ahead and they added some lead to try to balance out the rotor, and in hopes that that would fix the problem. But obviously it didn't fix the problem. So I went ahead and I scraped most of that off. And the reason why I scraped it off is because I want to try to eliminate as many variables as possible. And If I determine that it needs weight, I'll add it later. But I want to take that off because I don't know if that was added by the factory or if that was just a fix that a previous owner tried to do themselves. Okay, so we've already gone ahead and removed the lumps of lead from the rotor to eliminate that variable. The next thing that I did was I took a little black spray paint and I spray painted the inside of the stator, and then I put the motor back together and I ran the motor again. And what I've determined is that the rotor is very, very slightly rubbing against the top of the stator, and that's what's causing the vibration. So after spray painting the stator with the black paint, now taking it apart, looking back inside of here, I could see where the paint is rubbed off, and right here at the top there's some paint missing, and it's a little bit shiny there, so I could see where that rotor, it's not a lot, it's a very, very small touch, but it's just enough to cause that vibration and a little bit more noise than the motor should be making. So we need to figure out exactly what's causing that problem. And what I'm going to do now is I need to check the alignment of the end bells. So that's going to be the next step in trying to troubleshoot this problem. Okay, so the next thing that I'm doing on this is I'm double checking all the mating surfaces of the end bells and the housing to make sure that there's, not a piece of dirt or a buildup of grease or paint or anything else in there that could be affecting the way that these two pieces fit together. It's imperative that the end bell fits on the housing perfectly in alignment, otherwise obviously that could push everything out of whack. So I'm going along and I'm re-cleaning all the mating surfaces and making sure that those are perfectly clean and free of any debris. So I feel like I have these end bells dialed in as good as they're gonna get. I went ahead and with a file and I cleaned up all of the mating surfaces, and then I actually filed them down just a little bit so that they fit into the housing better. Before, when I would put them in, they fit in there, but I had to use a hammer to kind of tap them in place, or use the screws to tighten them down so that they would snug up. But now I can fit the end bells on there snugly, but I can fit them on there by hand. So since I had this thing apart, I went ahead and I removed the paint that I applied to the inside of the stator for that little test. And while I was at it, I also put another coat of varnish on these windings, and I got everything cleaned up. So we're going to go ahead and assemble it for the final time, and we'll give it a test run and see how we did.
So now the motor is finished, and I feel like I got it dialed in as good as it's ever been. It's really running smooth now, and it's running quiet. After looking back at everything, I have no doubt that that problem came from the factory. It appears that when those end bells were machined, that they just weren't machined exactly concentric to the bore, and more than likely whoever had this motor since then was battling that vibration problem. So I busted taking this motor apart probably about 25 times, just filing a little bit off, putting it back together, testing it out, just trial and error, getting it dialed in exactly where we wanted it, and now it's running smooth and quiet, and I'm real happy with the way that it came out. So started out looking like it was going to be an easy restoration, but it ended up taking a lot more time than I anticipated. So I hope you enjoyed following along, and we look forward to making the next video. Thank you for watching.